Matrix, like everyone know what matrix looks like. Is like put numbers in the rectangular box, and the entries are like all these numbers. They are called entries. We can use capital letters to represent matrix. Like A is a matrix. Capital A is this matrix. We use that to represent matrix. And if I say matrix A is that, and the lowercase a 2 1 means row 2 and column 1 number, so which is -1. So that's some notation thing. The important thing is about the dimension or the size of the matrix. So it's the number of row times the number of columns. So how many rows do you have? How many columns do you have? So it's the number of row times the number of column. So if two matrix needs to be the same, which means like all the entries needs to be the same and must be at the corresponding position. So this matrix is 2 times 2 matrix, 2 times 2 matrix, but they're not equivalent because the entries, like even though all the entries are the same numbers, but they're not at the correct place. So they are not equal matrix. If you want to add or subtract two matrices, you must have them have the same dimension. Okay, you must have the same dimension. Otherwise, you can't add or subtract between matrices. Okay, example 1. So if you have example 1, you should have answer A plus B is that, A minus B is that, B minus A is the negative of A minus B. So shouldn't have any problem between that. So you just add corresponding place or subtract corresponding place. So B is scalar factors, like you times the scalar factor in front of the matrix, you will have like just times every entry by that factor. So the next question you have 2a plus x equals to b. So 2a plus x equals to that. You can put the 2 inside the matrix, okay, times the 2 inside the matrix, and use this b minus 2a. So you will have x equals to -6, -8, 0, and 6 for the x. Multiplications between matrix. If you want to multiply between matrix, you must have them with the same order, not same order. The front one's column, number of column needs to equals to the number of rows for the second one. So that's what I said on board. So the right hand side see here, if it's an m times n matrix and the other one is a k times q matrix, you must make sure the middle two numbers are the same. Then they can times together. You will get something with dimension m times q. So that's how you times with that. So for the first question, if you think about A times B, okay, I show this in quite a lot of detail. So A times B, we use the row for the first matrix to times the column with the second matrix. There are 2 times 2 matrix. They're all 2 times 2 matrix. So it also will be a 2 times 2 matrix as well. To use the row 1 times the column 1. Okay, this is the row 1. This is the column 1. So those 2 times together will give you row 1, column 1 answer. So 1 times 5, 3 times 6 will give you row 1, column 1. You're adding them. And then row 1 times column 2. The answer will go to row 1, column 2 place. Can see, use the row 1 to times the column 2. That also will go to row 1, column 2 place. So that will give you a 10. Then row 2 and column 1 you put here. Row 2, column 2 you put it here. So you will be at the position which you use, and that will give you the correct position here. So you will have an answer like this. Yeah, 23, 10, 32, and 10. If you use B times A is here. And B times A is here. So you have answer 9, 17, 18, and 24. Again, B will be right in the front and A will be at the back. And then you use row 1, row 2, column 1, column 2 times the row 1, column 1. 1 times 5, 1 times 4 give you the 9. So you have 9, 17, 18, and 24. What I want to show you is, even though A times and B times A, they all can be evaluated, but they are not the same answer. Okay, you see that A times B is that, B times A is that. They are not the same. So I write here, A times B is not equivalent to B times A. They are not the same thing. So for the next one, if A is that, B is that, I want to find AB and BA. So AB is here, 3, 2, -1, 1, and 1, -1. That's a 2 times 2 matrix. That's a 2 times 1 matrix. The middle two number are the same, which is the tick is working. So you will have a 2 times 1 matrix, row 2 and column 1. 2 times 1 matrix. So row, I always circle that. It's easier for me to think about. So that's the row 1, that's row 2, that's column 1. You have row 1, column 1 put here. Row 2, column 1 put here. So the answer will be 1 and negative 2. Okay, so it's 1 and negative 2. But row B times A, you have 2 times 1, 2 times 2. 1 is not equivalent to 2, so you can't define that. So undefined. So undefined. So B times A is undefined, but A times B is a 1, negative 2. So for number 3, okay, so if A is that, X is that, so I want find A squared and X squared. Obviously, X squared is not going to define. So it's a 2 times 1 and 2 times 1. So the middle 2 is 1 and 2. So it's undefined for X squared. It's undefined for X squared. So A is a square matrix. What's a square matrix? N times A is a square matrix. So square matrix can find this square, like power of N, like power of 3, power of 2, that's fine. So you will have 2 times 2, 2 times 2. So again, the same thing. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So you have a square matrix as well. So the answer is 5, negative 6, negative 6, and 17. Just checking answer with you. Square matrix, as I said, is N times N matrix, and identity matrix is a square matrix with the main diagonal got 0, I got 1, and anywhere else got 0, so that's an identity matrix. So the important thing for identity matrix is identity matrix. Where is it? Where? Oh, here. A times I times A, they all equals to A. So it's like 1. Identity is like 1. 1 times any number still equals to that number. And any number times 1, that still be that number. So identity matrix is exactly the same as 1. But this A needs to have the same dimension with the I. So for example, A is a 3 times 3 matrix. And identity is a 3 times 3 identity matrix. So they are equivalent. Why we introduce that? Because we want to talk about the inverse function. In year 12, we only consider about 2 times 2 matrix to talk about the inverse. So 3 times 3, we use another method. We no longer remember the formula for 3 times 3 matrix to find the inverse. Uni, if you learn matrices, like there will be another way. Like I think it's in linear algebra. It's another way to talk about matrix. But 2 times 2 is a special one. There's a formula for that. It's the easiest one. Okay, that's the easiest one. So you can remember that and directly apply the formula. So the formula is 1 over AD minus BC, but it's not finished. You need to swap those two, the main diagonal, and you put negative on the other two numbers from the original one. How to change that to that? So what's the inverse matrix? Inverse matrix times the original matrix should give you identity. And the inverse and original matrix times the inverse will give you identity as well. So A times A inverse or A inverse times A will all give you identity. So but only square matrix will have inverse. Okay, only square matrix will have inverse. So 1 times 2 times 2, 3 times 3 matrix will have inverse. So determinant. So very important for determinant, AD minus BC. So A inverse does not exist if determinant equals to 0. That's like really makes sense because AD minus BC is the denominator. If you have something denominator equals to 0, how I can find inverse? No way, because 1 over 0 is undefined. So that really depends on whether you matrix A will have an inverse or not. So if you cannot have a if determinant is not 0, then we will have A inverse existed, like it will exist. Because I can always swap the number of those two, I can always negative the other two, but the only restriction will be the denominator. If the denominator is not 0, therefore we will have a inverse matrix. We will say that's a regular matrix. But if determinant equals to 0, A inverse does not exist, we will say that's a singular matrix. It's just the two name of matrix. Some square matrix will have inverse. Some matrix will not have inverse. So the one who don't have an inverse, that we'll call the singular matrix. Okay, so the example for the inverse. So we think about the determinant of A. So AD minus BC, AD minus 2 will give you 16. And A inverse will be 1 over 16, 1 over 80 minus BC. Swap those two, swap the main diagonal, so 6, 3. Negative the other two, so -1 and -2. So there's a factor, we put the factor in, we can have that matrix there. But sometimes, if you have another matrix you further wants to time with, do not put the 1 over 16 in yet. Okay, if you have another matrix to talk about, like it times another one, use this matrix times the other one first, and then put the number in, which makes the calculation easier. Otherwise, you carry a fraction 1 over 16, so it's really hard to calculate. So, okay, the important thing is here. Now, we have ax plus b equals to c, where b equals to that, c equals to that, a is given in the front. So, I'm not putting any number in yet. I'm just talking about how we can apply the inverse function generally. So ax plus b equals to c. So first of all, let's ignore the red thing. Okay, ignore the red thing. So ax will equals to c minus b. Okay, ax will equals to c minus b. Remember when you do, for example, 2x equals to 4. What x equals to? What do you do? A linear equation, 2x equals to 4. Divide by 2, right? Divide by the coefficient. You want to make the coefficient become 1 to have the single x there. But in matrix, we can't do division. Okay, we can't divide matrix A by matrix B. We can't do that. So what we can do is times the inverse to make two matrix become identity matrix, which become the coefficient 1. Then it will work. So therefore, I will times the A inverse on both sides of the equation. But very annoying thing is the matrix have order. You need to consider about order. Like x times 2 and 2 times x will be the same thing. But in matrix A times x and x times matrix A will be different things. So this A needs to times in front of this whole equation. Here, see, I want to make those two connect together. We can't just insert the A here. We can't just insert it anywhere. We can either put into the front or put at the back. But we must put like Ax. Well, we either put it here or after here. But we can only put it in the front to make those two connected together to have identity matrix. If we have Ax and A inverse, what's that? I don't know what's that. Like I don't have identity. They're not together. You haven't times those two together. Also, you can't swap things like as you want. So you must put this A inverse in front. Therefore, A inverse must be in the front of the whole equation on the right hand side as well. Okay, you put A inverse in the front of the left hand side. You must put A inverse in the front of the right hand side as well. So that's why I said A inverse here and cross it out. You can't have A inverse there. It's on the wrong spot. Okay, it must be in the front. And then A inverse and A become the identity matrix that become I times X. And you know I times X will just be X. So it's just X. So X will equal to A inverse times C minus B. Okay, X equals to A inverse times C minus B. I'm just not putting the older numbers in. So that's a general equation. So X will be, okay, A inverse, we just work it out. It's 1 on 16, 6, -2, -1, and 3. That's A inverse. We just work that out. And then times C minus B. C minus B, you use C minus B. That's -1, 5, 0, and 4. That's C minus B. So that's how we find A inverse and C minus B is here. So we now need to times those two matrices together. That's what I said. Do not put the 1 on 16 in yet. We time those two matrices first and then put 1 on 16 in. So after we times row 2, column 2, row 2, column 2, we'll have a row 2, column 2 answer. So you time those two at -6, 22, 1, and 7. Now you put the 1 on 16 into the fraction to find the answer. X is a 2 times 2 matrix with that answer. So we use this idea to solve for simultaneous linear equations. Normally it's a 2 times 2 matrix, but it can be solved for 3 times 3 matrix. If you can have a look at the next question. First of all, I must tell you, like if you also use matrix to solve simultaneous linear equation, doesn't matter how many equations you have. you need to have Ax plus By equals to C4. Okay, you need X plus By. Well, it's not necessarily C. Let's say K, like a number. X plus By equals to K4. So for the first equation, I must have minus 4x plus y equals to 3. And for the second equation, I must have 5x plus 2y equals to minus 6. I know there's more than one way you can write this equation. Well, you can say that's 5x minus 2y equals to 6, but doesn't matter, they are the same thing. So just you need to give me something in this form, Ax plus By equals to C4. And then you need to set up the matrix. So how do I set up the matrix? Well, it's exactly the same. You just hide all the x and y values and see the coefficient. Write the coefficient exactly in the same order. So minus 4, 1, minus 5, and 2. Okay, so minus 4, 1. Okay, can you see that's just a square box. So minus 4, 1, minus 5, and 2. Then you times the xy at the back. And then that equals to the k value. Okay, so in the exactly same order. Can you see that's exactly already looks like the matrix? So the coefficient, the answer, and you just put the xy times with the coefficient. So that's the coefficient box. That's the variable box. Okay, so your variable just write in the order of what you write. So you write x first and then y. So you write x first and then y. Okay, so that's how you set up the equation. If you have a 3 times 3 matrix, well, I'll write it here. So if you have a 2x plus y plus 2z equals to 1, 3x plus 2y minus z equals to 4, and then minus 2x plus 3y plus 4z equals to 10. So if you have 3 times 3 matrix, it needs to be Ax plus By plus Cz equals to K4. Like some x plus some y plus some k and then equals to something. Therefore, it's again in the same order. 2, 1, 2, 3, 2, negative 1, negative 2, 3, and 4. X, Y, Z equals to 1, 4, 10. But I can swap the whole row. Okay, do you understand? I can swap the whole row. I can say, I can put negative 2, 3, 4, and the 10 on the above line, and then put those 4 numbers at the back. Because I can swap between those 3 lines. They are the same thing. So in some multiple choice, they may not necessarily have exactly the same order as the question gives you, but like they will swap like in parallel ways. Okay, so put this line at the back and this line on the top. They're trying to change the order. So you need to recognize that. But it will be the same way as how we write 2 times 2 matrix. And the front one, how do we solve for that? So we have that matrix already. So now I want to solve for xy. That seems like the coefficient of xy. So I don't want the coefficient. I need to divide it, but I can't divide. I can only times the inverse of that matrix. So I'll times the A inverse in the front. Therefore, I'll times the A inverse in the front of right-hand side as well. So I'll put A inverse in front of the matrix B. So what I will left is only xy here. Okay, only xy here. So A inverse, that inverse times B, I will solve out like the whole thing here. Okay, so AB minus BC, and then swap those 2 minus the other 2 and times with that. And in the end, you solve out x and y equals to minus 4 and minus 13. Okay, minus 4 and minus 13. Don't have that much time, can't go through a single step with you, but that's the idea of how we should do it. We'll use matrix more to solve the simultaneous equations tomorrow. Talk about the number of solutions, which is the very typical question. I think you've seen it in year 11 already. So tomorrow we are talking about another way of solving simultaneous equations.